So you need to take notes from the next slide onwards. Basically, everything that I write down on here, you have to have written down in your notes, and I will be checking it for Tuesday. So we're going to start off with a reminder. The reminder is this. Okay, this is the equation of a circle. You should have learnt this last year. Okay, x squared plus y squared equals r squared. Okay, this is a unit circle whose centre is on the origin. Now, when doing calculus, what we're looking for a lot of the time is equations of tangent lines. Now, of course, circles have tangent lines. Here I go. I can draw some on. I can draw a nice one on here. I can draw one here. Okay. So what we're going to do in this chapter is find the equation of tangent lines to things like circles. Now, I don't know if you remember, but a circle is not a function. Why is it not a function? Okay, because it doesn't pass the vertical line test. Yeah, we have one value of x with two values of y. Yeah, if I was to put a vertical line through here, it would cross my circle twice. Okay, so copy down this reminder. Just sketch yourself a circle with an equation and write in big letters that a circle is not a function. Okay, and here's another reminder. Okay, this reminder is of the chain rule that we did just last chapter. So my chain rule states that if I have some h of x that is actually a function inside a function, so some f of x inside a bigger function, then my derivative of that big h of x is the derivative of the outside function g multiplied by the derivative of the inside function. Okay, and we're going to see why that's relevant in just a second. If you remember from the last slide, what we're looking for is the derivative of this circle here. Okay, but we don't know how to do the derivative of these kind of things. We've only ever seen y equals something. Okay, so let's have a look at how we work this out. So what we do is we put a derivative operator on both sides. Basically, to find the derivative of the whole thing, in order to find a tangent line, we work out the derivative of this side and the derivative of that side. So let's do it. First part is easy. X squared, the derivative of that by x is just 2x. We've done that a million times. Now for the next part, y squared. We are finding the derivative by x. Okay, so we need to do the following thing. The derivative of y squared will be 2y, but our y is a function of x. It's a compounded function, so we then need to multiply it by the derivative of y. Remember, whenever we do a derivative, we can only differentiate or derive by one variable at each time. Here, we're deriving by x. Okay? So when we want to do y, we assume that y is some function of x. It's some hx that is a y of x. Okay? So when we find the derivative, we have to do 2y, which is just the derivative like x, multiplied by the derivative of y. Okay? And then on the other side it will be easy. On the other side it will be easy because the derivative of any plain old number is just 0. Okay, so now we've got this equation like this. What we're looking for is the derivative of this function, is this y tag. So now we can just isolate this y tag over the side. We just need to move this x over here. And now divide by 2y, and we get y derivative equals minus x over y. Okay, this looks a bit different to what we've done in the past. In the past, we've had a y equals something with a load of x's, and we've just found the derivative. This time, we're working with something that isn't a function. Okay, so the derivative looks a bit strange. But once we have something like this, we can then find the tangent line. Okay, let's go look at the example again. So you don't need to copy out this sketch again, okay, but do copy out what I'm about to write now. Okay, so here this is our question. Find the equation of the tangent line to this circle at the point 1 square root of 3. Now, of course, to find the equation of the tangent line, we need a slope and we need a point. They've given us a point, so we need to find a slope. Finding the slope, it means finding the derivative. And in our last slide, we found that our derivative was y equals negative x over y. And now we're done. Why are we done? We have our x, that's 1. We have our square root of 3. We have our y, that's square root of 3. So, our derivative is therefore okay, if you want to simplify this equals, okay, this is our slope. We have our slope, okay, we have our point, rest of it is easy peasy. So we know that y equals okay, plug in my point. Okay, there's my tangent line. I've basically done exactly the same as I've done every time. I've been given a graph, not a function this time, and I've asked to find the tangent line. Found the derivative, okay, plugged in the point, found the slope. That's it. So you need to have this example written down. We're going to do another 1 or 2 examples, and then we're going to do many more examples like this in class. But you need to have watched this before you come to class. Okay? So, have you ever seen a function that looks like this? I hope the answer is no, because this is definitely not a function. It doesn't pass the vertical line test at all. If I put a line down here, it crosses over the function once, twice, 3 times. Okay, so this is not a function. However, we can still draw some tangent lines to it. Here, for instance. Okay. This point is 3, 3. Okay, so at that point, 3, 3, there's a tangent line to the function, or not to the function, sorry, to the graph of this equation. So we want to find the equation of it. So our equation is this, and we are going to differentiate each side. Okay, we're going to put on a differentiation operator. Okay, so we'll get 3x squared plus 3y squared times the derivative of y, because it's the chain rule, equals, now this side it's the product rule, so it's 6y plus 6x y derivative. Now what we're going to do again is isolate my y derivative over to the left and everything else over to the right. So first we're going to put this here and that there. Okay, you need to be writing this along with me. So here is an expression of our y derivative. Yeah, just like in the previous example, this has x's and y's in it. Okay, before in previous chapters when we got to y derivative we only had an expression with x, but this time we have x and y's. Now we have our point is 3, 3, so we're just going to plug that in and then that will give us a slope. So it's 18 minus 27, that's minus 9. Okay, so that's our slope, minus 1. So we know that our function looks like y, or our equation of our tangent line looks like y equals negative x plus b. Yep, and now to find that b, we just plug in 3, 3. Yep, so we get... Okay, so we just plug in our points into here, 3, 3, and we get... Okay, so before we do the next example, I want to do some reminders for trigonometry, and you need to write these down as well. So my first reminder is sine x squared plus cosine x squared always equals 1. Okay, and from here we get that cosine of x equals the square root of 1 minus sine x squared. Yeah, this is sometimes useful. This one is very useful when the questions we're about to do. Okay, the next reminder is of the inverse trigonometric functions. So if sine x equals a number, okay, then we put on the inverse trigonometric function and we get that x is sine minus 1 of y. Okay, this is not 1 over sine y, this is a different function. Yeah, you may have also called it in the past arc sine of y. Okay, this just tells me if I want to know, for instance, I don't know, which x's give me sine x of 0.5. Okay, Okay, to solve that, in my calculator I need to work out arc sine of 0.5. Okay, and that will give me pi over 6. Yep, in your calculators, to do it, you press the shift button and then sine. That will give you arc sine. Okay, arc sine or sine minus 1. It's the same thing. Okay? So all the trigonometric functions have inverse trigonometric functions. Okay? Sine, cosine, tangents, and cotangents. Okay? It just means the opposite way round. You're looking now for an x that gives you that value. Okay? Try it out in your calculators if you don't believe me. Okay, so my next example, y equals inverse sine x. Okay? Please make notes, okay, that this does not equal 1 over sine x. That's not what this symbol means. Okay, this symbol means something else. It means arc sine of x. And if you still don't know what that means, go back to the last slide. Okay, and if you still don't know what that means, go back to chapter 1.6. Okay, the best way to get comfortable with these is to try it out in your calculator. Press the second blue button, shift, and then cosine or sine. Okay? So we know that if y equals arc sine x, then the sine of y equals x. That's exactly the definition. Okay? We want to find the derivative of this function, of this sine negative 1x. Okay, so what we're going to do again is put a derivative operator on each side. Okay, and we're also again deriving by x. So it will be cosine y times y tag, yeah, with the chain rule, equals 1. Okay, so now y tag equals 1 over cosine y. Okay, isn't that cozy? But if you remember in our slide before, we had a reminder, and we could write y tag or cosine y equals the square root of 1 minus sine squared y. Okay, and even further than that, we know that sine y equals x. So instead of sine y, we can just substitute for x. Okay, so we found that the derivative of arc sine x is 1 over the square root of 1 minus x squared. We could have kept it like this, but it's always easier to work with something with x's. Okay, so it was much easier to do this. Okay, now what we found are the laws to find the derivatives of the inverse trigonometric functions, and they will be on the next slide. Okay, so here you have the list of those derivatives. The derivative of arc sine that we just found, the derivative of arc cosine, and the derivative of arc tangent. Okay? Okay, so I want you to complete one question at home. It's very similar to what we just did. I want you to prove to me, okay, the derivative of to find the derivative of that, not just from the formula, to do exactly what we did in the slide before last. Okay, so the first step will be to write and now put a derivative on both sides, and you'll need to end up with the formula in the previous slide. Okay, so I want to see this question solved in your books. Okay, so that's it for chapter 3.5. I want to see these notes in your notebook. You need to check the date. It needs to be handed in by on e-learning because it's different dates for different classes. Okay, thank you.